Hi folks, welcome to this video where we're going to take a look at example 11 and 14 from the chapter 8, My Open Math. All right, so let's get started with example number 11. The question says we would like to estimate the percent of adult residents in a certain country that are parents. Out of 300 residents sampled, 168 had kids. Based on this, construct a 95% confidence interval for the proportion P of the adult residents who are parents in this country. All right, so let's get started. Okay, so we're taking a look at this, and one of the things that jumps out at me immediately is I look at this word proportion. So I don't see anything about a mean or an average, but I see something about a proportion, okay? And when we're looking at these proportions, what we need to do is think about what is our sample and how many times we're quote unquote finding success, okay? Now that phrase should sound familiar because way back in chapter 4, we talked about something called the binomial distribution. And in the binomial distribution, one of the things we had to look at to classify it as a binomial distribution is it had to be either success or failure. Okay. So in this case, we're looking at a sample size n equals 300 adults. Okay. And what we're trying to see is like how many of them are parents, right? So in this particular sample, 168 had kids, okay? This is what we're going to consider the success part of the binomial distribution, okay? Now we can go ahead and find our p hat, or we can call that a point estimate from our sample. Okay, point estimate from our sample. And that's just going to be the probability that we found the success. In other words, 168 over 300. And if we type that into our calculator, we get 0.56. Okay. Now, remember in all the other ones that we've looked at in terms of looking for that for the diagram where we're saying, oh, this is our average, and then we can sort of go out in both directions to find that confidence interval. That's what we're going to be looking at here. So let's go ahead and go over to StatCrunch. Okay, I'm going to clear out of this old screen. I don't need this data, but I'm going to go to Stat, and I'm going to go to the proportion stat. Okay, so I don't want the T stats because it's not that I'm looking at an average, but I'm looking at proportion, so I have to choose proportion stats. One sample, and we don't have exact data values, but we do have summary. Okay. So number of successes, we have 168 adults who have children. And the number of observations, this is out of the 300 adults that we asked, okay? Now, again, we're not at our hypothesis testing yet. That's going to be for later on, but we're at a confidence interval. And we want a confidence interval of 0.95. Now, the method doesn't really matter. Whichever one is there is fine, okay? And I'm also going to click on that confidence interval plot so I can see a picture of what I'm looking at. Okay, so let me go ahead and compute that. We're going to make that screen bigger. And we see that we have our lower limit and we have our upper limit. And that is around that sample proportion, okay? So 0.56, so 56% of this population had children. But if I wanted to ask every single adult in the entire county, I am 95% sure that between 50% and 61% of the parents, like on the average, that the average number of people who are parents would be somewhere between 50 and 61%. Okay. And I'm 95% sure that this is true. And so if we look at our diagram just to see what the confidence interval looks like, okay, let me get rid of those pictures. Okay, so we can see here now that this is our proportion of success, our 0.56 or 56% of the adults that are asked are parents, but 50% and 61.6%, the true proportion is somewhere in between here, okay? The true proportion is somewhere in between here. Okay, so let's take a look at what they want us to answer in the actual question, okay? So it says express your answer in tri-inequality form. Give your answers decimals to 3 places. And so let me go back one more screen so I can see the numbers that I'm interested in. But when I'm expressing my numbers, I'm looking for that lower limit to the upper limit. And the lower limit rounded to 4 decimal places is 0.5038. And the upper limit rounded to 4 decimal places is 0.6162. Okay? Now, the second part sounds complicated, but it's actually just showing us a different way of writing things. And in particular, it's showing us how we might write it like the pictures given here. Okay, so let me show you on the picture what I mean. So I know that this is 0.56 over here, but I know that I got to this 0.616 by adding a certain value. And it turns out that I take 0.56 plus 0.056. That will give me this value, okay? Now, if I want to find out what's happening in the other direction, it's 0.56 or that mid one minus 0.056. And that should give me that percentage right there or that proportion, okay? Now, you might be asking, how did you get this 0.056? And that would be important for me to tell you, okay? So the way I got it, I know that my midpoint is 0.56, but the way I got how much I'm plussing and minusing is I just took the upper one, 0.6162, and I subtracted 0.56. And when I subtracted that, let me make sure I've got the right numbers here. When I subtracted that, 0.6162 minus 0.56, I get 0.056. Okay, so that's how I know what this number was over here. Okay, so I didn't just get it from nowhere. I got this number because when I subtracted over here, that's the number it gave me. Okay, so I hope that was helpful for number 11, but let's now move on to take a look at number 14. All right, let me clear out this screen over here and we'll get rid of our annotations. Okay, so example 14. Example 14 says, giving a test to a group of students, the grades and gender are summarized below. And so we've got this lovely table here of all of these values, but we can see that they really break the students down into male and female students, and then the grade that they got, A's, B's, or C, okay? So it says, let P represent the population proportion. Oh, there's that word again, proportion, right? So we're not going to want to use our T distribution. We're going to want to use the proportion stats. All right, so we want to find the proportion of all male students who received a B on this test. Use a 99.5 confidence interval to estimate P to 4 decimal places. Okay. So looking at this information, we know that our sample is all male students. And we can see from the table that that's just 32 students. Okay. Now, what is our measure of success? We're measuring their success if they got a B on this test. Not a B or higher, just a B. Okay. They earned a grade of a B, and that is 16. So when I take my p hat, I'm going to take the success divided by the total, 16 divided by 32, and that gives me 0.5. Okay. Now, this point 0.5 is not what goes in these two boxes, but the point 0.5 is going to help me fill in my table or my information in StatCrunch. Okay, so let me go over to StatCrunch. We're going to proportion statistics one sample because we've just looked at this one group of students, and we're going to look at it with summary. Okay, so how many successes did we have? We had 16. How many observations? Well, we had 32 male students. We want a confidence interval, but we don't want 0.95. We want 0.995 to get that 99.5% confidence interval. Like we want to be super, super sure that our proportion is in between these two values. All right, let's do a confidence interval plot 2 just for fun. And let's see what we get. All right, there's our upper and lower limit. Okay, so the lower limit is 0.2519 and the upper limit is 0.7481. Okay, so what does this mean? Okay, this means that somewhere between 25%, 74%, all right, that the true proportion of male students who earn a B on this test is somewhere between these two numbers. In fact, we are almost 100% confident. In fact, we are 99.5% confident that the number or the proportion of male students who earn a B is somewhere between here. Okay, so I hope that was helpful. Let me know if you have any questions, and I will talk to you soon.